Let's take a look at integer exponents, but first we want to recall these exponent rules. So the first one is 3 squared. 3 is the base and 2 is the exponent. The exponent tells you how many times you're going to multiply the base by itself. So 3 squared is simply 3 times 3 is 9. But in the next one, when you have negative 3 squared, it's like saying negative 1 times 3, and your answer is negative 9. This is going to be a little bit different from when you have the quantity of negative 3 squared, because this is saying it is negative 3 times negative 3, which gives you positive 9. Because of these parentheses, the whole base, negative 3, is what needs to be multiplied by itself. Up in the one above, really the only thing that's being affected by that exponent of 2 is the 3. This negative is considered separate, which is why I think of it as a negative 1 times 3 times 3. Take a look at the bottom one. The quantity of negative 3 cubed is negative 3 times negative 3 times negative 3, which gives you negative 27. So what you need to remember here is when you have these parentheses, your answer, positive or negative, will depend on the exponent. If you have an even exponent, your answer will be positive. If you have an odd exponent, your answer will be negative. However, when it's just negative 3 squared, like the example in red, your answer will always be negative. So if you had negative 3 cubed, it's negative 27. Negative 5 squared is negative 25. Negative 4 squared is negative 16. So just keep this in mind as we're moving forward with our unit on integer exponents. So let's take a look at these notes. We're going to look at some patterns here. We have 3 to the 4th, 3 to the 3rd, 3 squared, 3 to the 1st, 3 to the 0, 3 to the negative 1, negative 2, and negative 3. So let's go ahead and take a look at 3 to the 2nd power. 3 squared, we know is 9. 3 cubed, we know is 27. 3 to the 4th, we know is 81. 3 to the 1st is simply 3. Any number to the 1st power is that number, any base to the 1st power. Well, what's 3 to the 0 power? If you take a look at what's happening here, you'll notice 81 divided by 3 is 27. 27 divided by 3 is 9. 9 divided by 3 is 3. Therefore, 3 divided by 3 is 1. And that works for any number. 10 to the 0 power is 1. 5 to the 0 power is 1. 1,000,000 to the 0 power is 1. But what is 3 to the negative 1st? And 3 to the negative 2nd, and 3 to the negative 3rd. Think about this for a minute, or pause your computer. If you are simply dividing, again, by 3, you're going to get 1 divided by 3. And then if you divide again, you get 1 divided by 9. And then 1 divided by 27. So what's happening here? When you have 3 to the negative 1, this base of 3 is being affected by this negative 1. We're dropping it down to a denominator. It becomes 1 over 3 to the 1st power, which is 1/3. And then with 3 to the negative 2, we're dropping it down. It becomes 1 over 3 squared, which is 1 to the 9th. And the same thing goes with 3 to the negative 3rd. So what happens? We don't want to work with negative exponents. We want to make them positive, but we need to be shifting things to the denominator if they're up in the numerator. So take a look at 2 to the negative 3rd. The 2 is being affected by that negative 3. So I draw my fraction bar, bring the 2 down. The negative 3 becomes a positive, keeping in mind what happened here. We need something in the numerator, so you put the 1 there. 2 to the third power is 8. So you end up with 1/8. Take a look at the second one. Negative 3, all raised to the negative fourth power. And I'm actually going to cross this one off because it's the same one. We have a negative exponent, but the whole thing is being affected. So we're going to put the 1 here, negative 3, and the 4 is positive. Now remember, the only thing that changes when we drop it down below this fraction bar is the exponent. The negative on the 3 still stays the same. It's in those parentheses. And then if you think about what we did up here, negative 3 times negative 3 is 9. 9 times 9 will give you 1/81. We'll look at a couple more practice problems in a second. Here's the example that I wanted to write. It's just negative 3 raised to the negative fourth power. So here's your negative exponent. I'm going to draw my fraction bar. We're going to bring the negative 3 down. Remember, the only thing that changes is the exponent. So that negative 4 becomes a positive 4. You need your 1 up there. So remembering the rules we said on the other page, there are no parentheses here. Your answer is always going to be negative. So it's like saying negative 1 times 3 times 3 times 3 times 3, which is 1/81. Let's take a look at 5x to the negative 2 power. So we have basically, this says 5 times x to the negative 2. What's being affected by that negative exponent? The only thing that's being affected is the x. Therefore, it's the only thing that's going to move. The 5 stays on top. Bring the x down, the negative 2 becomes a positive. That's your final answer, right here. Let's take a look at the next one. 3x squared, y to the negative third power. It's the same thing as saying 3 times x squared times y to the negative third. I like to draw my big fraction bar, and then I'm going to just go through each term. Is this 3 affected by a negative? No. Keep it up there. Is this x squared being affected by a negative exponent? Nope. Keep it up here. Is this y to the negative third being affected by a negative? Yes. Bring it down, and it becomes a positive. That should probably be, looks more like an exponent. Make that a little neater. And that's your final answer. Let's take a look at another practice problem on the next page. All right, let's take a look at this one. Remember, when we substitute, we have to use parentheses. We took our oath, always use parentheses when we substitute. So this is x to the negative first power if x is 2. So I have 2 to the negative first power. Can't have a negative exponent. Got my fraction bar. Bring that 2 down. Now becomes 2 to the positive 1. There's nothing up there, so I got to add a 1 there, which is 1/2 to the first is 2. So you got 1/2. So now we have x to the 0, b to the negative 3. So there's a couple ways you can solve these. The first one, I just substituted the 2 in for the x, and then I dealt with the negatives. In this problem, or in any others, you could always get rid of those negatives first. It's up to you. So you could say, well, that's got that negative on it, so I'm going to make that positive right now. The x has the 0 on it. It's not negative, so it stays in the numerator. The negative 3 on the b means it has to drop. I'm going to draw my fraction bar, and then I'm going to substitute. 5 to the 0 power negative 2 to the third power. Any number to the 0 power is 1. Negative 2 times negative 2 times negative 2 is 1 over negative 8. P to the negative third power, I'm going to make this positive and then substitute. Oops, no, 3 to the third power, which is 1 over 4 to the third power, which is 1 over 4 times 4 times 4, which is 1 over 64. We'll work on more of these tomorrow.